Now we'll see timestamp concept. So we have three kinds of timestamps. One is timestamp of a transaction. Second one, timestamp of read timestamp of a variable, and write timestamp of a variable. We'll see one by one. So what is timestamp of a transaction is every transaction is going to get one unique identification number. So it depends on the software. So one easy idea is your DBMS can give system generated number. That means based on the time, otherwise anything. So it is going to give every transaction unique identification number. In academics, in our discussion, what we do is rather than creating a system time, we do like this. So the suffix will be going to be timestamp. That will be easy idea for us from now onwards. So T1's timestamp, I do like this. Timestamp of T1, I assume 1. Timestamp of T2, I assume 2. And timestamp of T3, I assume 3. And one more thing, so this 1 I give to oldest transaction. That means the transaction which is created first. In that way, 2 is a transaction which is created after 1. That means a transaction T1. Similarly, I give largest number or highest number to the transaction which is youngest. So in that way, based on the value of the timestamp, we can decide whether it is younger or older. Remember it. Example, timestamp of some transaction Ti is greater than timestamp of Tj. That means what from now onwards? Let's fix the numbers and we imagine. Timestamp of Ti is 6, timestamp of Tj here is let's say 4. 6 greater than 4. What does it mean? So by seeing the numbers I can easily say, right? 6 means younger, 4 means older. Such a way we are giving the numbers, correct? So definitely Ti is the younger transaction than this Tj. Otherwise Tj is the older transaction than Ti. In that way we can imagine these timestamps. Now we will see what is read timestamp and write timestamp. So read timestamp is a timestamp of a transaction, but which transaction? A transaction, youngest transaction which read this data item A. Among all the transactions which read data item A, youngest transaction's ID will be written here. Similarly, write timestamp of A is a timestamp of a transaction, but whose timestamp it is? It is timestamp of a transaction which is youngest transaction among all the transactions which wrote this database item A. Example, let's say at 9 o'clock. So finally our idea is we are going to maintain these two. Using software, we are going to maintain these two. If I maintain them, what could be the value of read timestamp of A at this moment? Initially it will be 0, 0. So my assumption 0 is not at all a timestamp, okay? Valid timestamp. Now see here, at 9 o'clock, after completing this operation, let's say here no logs, nothing, okay? So far we are not discussing protocols. Somehow let's say read of A is done by T1. Then what will be the timestamp of A here? Simple. Because so far transaction 1 is the only transaction which read this data item. So it will be the 1. Next, when control comes here, whenever time is at 10 o'clock, then assume that let's say this operation is done. I'm not telling that this operation will be done. If this operation is done, then so I can say that T2 is one of the writer of B. Then we are going to update read timestamp and write timestamp of B's. So what is write timestamp of B this time? Since some writer who is nothing but T2 wrote it, correct? So this will be the recent one, right? Otherwise youngest one. Now after that, after completing this task, so read timestamp of C and write timestamp of C will be updated, correct? But which one? Read timestamp, because it is reading, correct? So now you tell me at this moment who is the transaction which is youngest among all the readers? T2, correct? That's why ID will be 2. Next, now you can understand. So time comes here, then write of C. So writer is now, who is youngest writer who wrote C? 3. Then who is the youngest C after reading B? So whose transaction, whose operation is it? T1, right? So T1 is reading B, then go to read timestamp of B, and what was the value so far? No, right? 0. Then update it to 1. In that way we do that. Then after that, the write timestamp is done. Now this one, read C. Whenever T1 reads it, go to read timestamp of C, which is already 2. That means so far youngest transaction who read time, this variable C is 2. But now after that, now T1 is reading, correct? don't make it 1, because according to semantics of read timestamp should represent youngest transaction number, which is a reader. So here youngest transaction among 1 comma 2 is whom? 2. That's why we should not change it to 1. So otherwise you remember one thing, the number should be changed from smaller to bigger, but not from bigger to smaller, because always we are going to maintain youngest transactions number. That's why this is not youngest transaction who read it, correct? We have other people. That's why this will not be updated, but operation will be done, but timestamp will not be updated, right? So this is the meaning of read timestamp of a, write timestamp of a. So using that we are going to see some algorithms. One is, basic timestamp algorithm. Second one, Thomas Wright rule. Using these two algorithms, we are going to control the concurrency. We will see how to do that. Okay. Now we'll see basic timestamp algorithm. So far we have seen what is timestamp, right? And what is read timestamp, what is write timestamp. Using that, we are going to define basic timestamp algorithm, which is going to control the concurrency. That means which is going to, avoid the concurrency problems like locking protocols. So we know what is locking protocol, everything, right? So here, what is the idea about basic timestamp algorithm? I will tell you. Finally, so your example, this is your set of transactions. That means schedule. So there is a schedule with some reads and writes. Let's say T2 has read and T1 has write. So finally, our goal of basic timestamp algorithm is this schedule is only allowed under this basic timestamp if transactions are allowed, following the timestamp ordering. That means the execution sequence of operations should follow this timestamp ordering. That means, example, T1's timestamp is 1, T2's timestamp is 2, then we say that T1 is older and T2 is younger. So always, first of all, older transaction should perform the operations, then younger. But we allow the concurrency. It doesn't mean that it's serial schedule. So here actually what is the problem with this one, why it is not allowed, I will tell you. The condition of the timestamp algorithms is the order of the execution should be this age, otherwise timestamp ordering. Now this is not timestamp ordering. Really in timestamp ordering, if they had performed these things, what happens? T1 has to, this is database item A, then really what is the timestamp ordering? T1 then T2. If this ordering is done, then T1 has to modify this data first, initially a value 10, let's say, then first if this is done, then a will become 20, correct? Now after that T2 reads, then T2 is reading what? So T2 is reading 20, remember it, but initial data was 10. But now in this order what is happening? T2 is reading 10, but after that T1 is updating. Of course we know that it's a read-write conflict, so we don't allow this kind of thing. Then what kind of thing you allow? Really, if in timestamp ordering, if transactions execute their operations, whatever the output you get, whatever is correct, the same thing we are going to do here. If the same thing happens, then only we allow. Now see, if really in timestamp ordering it is done, you will be getting definitely different answer. That's why your timestamp algorithm is going to reject it. How it is going to reject, we will see. First understand what are the things are going to be rejected. But it doesn't mean that it allows only serial schedules. See, this is this one. Example, T2 is younger transaction. Let's say T2's timestamp is 2, T1's 1. So who is younger? 2. So T1 is older, right? So actual ordering should be T1 followed by T2. Then only we allow. But what if T2 reads first, then T1 reads, then basic timestamp algorithm doesn't have any problem. The reason, whatever the way they read, same thing they are going to do, correct? So there is no effect on the database. So there is no different effect, right? But see this situation, if T1 writes first, sorry, this one, if T2 writes first, then T1. Actually, what are we, preferring in this basic timestamp algorithm? Timestamp ordering. If what is the timestamp ordering? T1 followed by T2. In the T1 followed by T2 order, really these two things are performed. What is going to happen? Initially a value, let's say 10. This write of A is going to make it 20. This write of A is going to make 30. Then obviously we know that, right? It's a conflict operation. If you change the order, you get different thing. So really timestamp based algorithm prefers T1 T2 order. That means first of all this should be 20, then 30. That means permanent result is 30. But if you do in this order, you are going to get 20. That kind of ordering, that means that kind of value is not preferred by basic timestamp algorithm. So why this entire thing? So that some if you have some ordering, so there will not be any cycle, correct? So when there is no cycle, then probably we don't have, I mean, the bad schedules. That means, so no interleaving problems. That is a rough idea. So I gave you intuition. Finally, we follow only one thing: timestamp ordering. If the schedule comes as timestamp ordering, if your schedule is designed in a timestamp ordering, then only it will be allowed. So we'll see one example: T1, T2, T3. First of all, we don't go to the code. First of all, we see the intuitive idea. See, read of A. So T2 read of A. Okay, so let me give reverse order: T3 read of A, T2 read of A, then T1 read of A, then suddenly T1 write of A. So whether it is allowed or not, we will see. Forget about basic timestamp algorithm. We have an idea about basic timestamp algorithm. So first, T3 is reading, not an issue. T2 is reading, though it is out of order, read doesn't matter. Again, doesn't matter. But suddenly T1 is writing, correct? So this is going to perform this writing before other younger transaction has to read. Then only that is timestamp ordering. Really, what is timestamp ordering? T1 followed by T2 followed by T3. In this order, really these things gets performed. Then T2, T3 are going to read what which is updated by T1. In current scenario, are they doing that? No, they are reading before the original value is updated. Correct? Original value means this order. In this order, this write of A is going to decide what to read. But that is not happening here. Then definitely your basic timestamp algorithm is going to reject it. How it will find out that some mistake is going on? So that is the trick. The trick is by read timestamp and write timestamp. So that's why we maintain read timestamp and write timestamp. Okay. What is the semantic of read timestamp and write timestamp of A? I will tell you. Read timestamp of A is nothing but youngest transaction currently who read this database item A successfully. And write timestamp of A is nothing but youngest transaction which wrote database item A successfully. So if you have this kind of operations, read of A, T2 read of A, T1 let's say read of A, not a problem, then this one is going to have problem, right? First, see, read of A, it is successful. First of all, according to our code, we should allow it. So such a way we designed it, we will read it and we'll try to execute it. Before that, you see, this read of A actually should be allowed. Yeah, for that what we do, yeah, we just put a mark. That is what my expectation. So then, since now who is the latest reader? T3, correct? So read timestamp should be updated to 3. Then only semantically it is correct. Now after that this will be done. So T2 is reading, it should be allowed because read doesn't matter. So now anyone can read at this moment now, but don't update it. Don't make it 2. The reason, who is youngest among these two? T3, right? So that's why compare this timestamp, T2, T3's timestamps you have to compare and we have to decide. Yes. Now after that this operation comes. When this comes, first of all we'll see so whether this read is okay or not. This read depends on what? This read is a mistake only when there is a conflicting operation. That means this T1 says that I am the oldest transaction in the system. I am now reading. Before that, no younger people should write it, should modify it. If they modify it, then I am not reading them in the timestamp ordering, correct? What is timestamp ordering? T1 followed by T2 followed by T3. Now you can imagine this thing as a story. So T1 is warning like this: Mr. T2 T3, I am young, oldest among all of you. Okay, so I am now reading, but please ensure that you people did not write it. If you write it, then definitely I am doing mistake. Definitely my thing will be mistake. So please ensure that please don't read it. Please don't write it. So we'll see whether it is correct or not. So T1 is reading here, right? But how your system knows that whether someone wrote or not? That's why write timestamp helps. So far write timestamp is 0. That means no one updated it, correct? So by seeing read timestamp and write timestamp, your system can know whether anybody or any younger transaction updated it or not, correct? So your T1 will be happy. It says, yes, this 0 indicates that no one did, no wrong thing so far has been done So I perform read of A. Then after that this comes T1. So DBMS will check again same thing. So now T1 wants to write, but see one thing. What are the mistakes at this moment? I will tell you. If younger transaction writes first before this one, see this story. T1, T2. Now T1 want to write, but before that younger transaction writes. Then definitely this is out of order. What is the correct order? I want only T1, T2 order. But this is T2, T1 order. There is a difference in these two. If you do in this way, there will be a different effect on database. If you do this one, there is a different effect on database. That's why we should reject it. So how your DBMS is going to check, I will tell you. Whenever this is going to be performed, DBMS will ask, who is the youngest? Any writer? So first of all, we'll see write timestamp. We'll see. So far, any writer is there? No. That means so far no one did mistake. We are in right order. But it doesn't mean that we are not doing mistake, because when you are writing, others should not read, others should not write. We have checked just now, others did not write. So far no one wrote it, correct? But we have to see the readers. Why? If there is a younger reader. But actually he has to read from T1, then only it is correct ordering, correct? But he read it before original person writes it, correct? So that means from now onwards, if you see this kind of thing also, we are going to reject. That means this is a read-write conflict, correct? So how to find out it? Simple. Go to readers and ask. Among all the readers, who is highest? 3. So here especially it is 3, correct? But actually now T1 wants to write. But now T1 says like this. Actually there is a mistake. What is that? You people should not read before I write, but you people already read it, correct? That's why some mistake happened. So we have to find out the solution. How this system DBMS is going to find out the solution, we will see. The solution is very simple. This T1 will be cancelled, that's it. When you cancel T1, then see the only problem now because of T1, correct? T1 made entire thing out of order. So we say that happily, so far system is good, because of you only now we are becoming out of order. Your DBMS will cancel it and it will restart it. That is what going to happen. From now onwards, any transaction issues an operation while performing, if you violate this timestamp ordering, such transaction will be simply killed. Okay. So what are the things going to make your system, otherwise your order violation? I will tell you. This one. T1, T2, there are hundreds of transactions, doesn't matter. Example, T1 is suddenly writing before this one, because it is oldest, right? No younger transaction has to read, no younger transaction has to write. So if someone reads or writes before this T1, which are younger, then definitely it's out of order. The correct order should be T1 followed by others. So this will be mistake. That we are going to check using read timestamp and write timestamp of each variable. Second one. While reading, example, some oldest transaction is reading, it will check this one. I am the reader, but I should read correct data. That means younger people, whatever they write, I should not read, because order is what? Older to younger. Then I will directly go to this writers. How to find out the writers who updated it? That's why write timestamp of A is the thing we are going to use for that. We'll ask directly, Mr. Write timestamp of A, what is your value? Example 20. That means among all the writers, the youngest person is 20. And example, your T1's number is 1. That means what? You have to read first, then these people should write, but reverse thing happened. So by this value we can check. You tell me what is the, when the condition will be true. Example, timestamp of T1 is, let's say, otherwise let's say this is T15. Whenever T15 wants to issue read operation, who should not write? T16, T17, T18. That means this write timestamp of A should be less than or equal to this 15. That is what we are going to ensure. If it is 16, then definitely out of order, correct? So now we will go to the algorithm. Let's read the algorithm. Stop the video and you read the algorithm. After that I continue. So first of all, any transaction want to write any data item, what are we going to do? So we are going to decide using this code module. What is that we will see? If read timestamp of T greater than timestamp of T, or if write timestamp of T greater than timestamp of T, if this condition is true, then we are going to cancel the transaction. We'll first of all, we'll come with our intuition. What is our intuition? our intuition is, whenever some transaction want to write, now you are the writer. So what is your idea, entire algorithm's idea? The order of execution should be timestamp ordering, correct? So now when you are writing, so this whatever you write, that should be read by others. That means younger transaction has to read your data, but they should not read before you. That's why I am going to check read timestamp. At the same time, if you are writing something, after that younger transaction has to write. So it's a conflict operation, right? That's why writers also to be checked. That means, so before you, no younger transaction has to write. How do you check it? Write timestamp. That's fine. So timestamp of t, if read timestamp, if it is greater, let's say, that means what? Younger reader already read it. Then you are out of order. Or if write timestamp of t greater than timestamp of t, your timestamp, let's say 20, and here 20. And write timestamp is 30. That means there is one younger person called 330. He wrote it already. That's why write timestamp of t is 30. He is the youngest person. So that person, and now you want to write it. But who should write first? You. Then he should write. But reverse thing already happened. That means what mistake has happened according to timestamp ordering. Then automatically you are so such now at this moment you are the first person doing mistake, correct? You did out of order. Then if you are cancelled, then remaining system is safe. It is following the timestamp ordering. That's why immediately abort and roll back t. So this timestamp 20 transaction will be cancelled and reject the operation. Of course, when you cancel the transaction itself, what's the meaning of accepting that operation, correct? And we reject it. And one more thing you remember, rollback means we cancel the transaction at the same time whatever it did throughout this execution of the transaction, that entire thing will be reverted. That means cancelled. Example, if it does a equal to a plus 10, we do a equal to a minus 10. That means whatever the effects your transaction t makes to your database, they will be reverted. Understand? So that is about write condition. Now we'll see else part. I mean, it's not completely done, right? What if this condition is false? We'll see the numbers so that this condition is false. Let's see. Read timestamp greater than times r condition, right? Then it should be false, this should be false, then only overall will be false. Let's fix timestamp of t to 20. So the read timestamp of t greater than 20 to become false, it should be 10. Okay. So read timestamp, let's say 10. Now write timestamp, let's say it is 15. 15 greater than 20 also false. False or false? False. Now see the situation. What could be the situation? So timestamp of t is 20. That means now currently there is a transaction. Its age is, let's say, its timestamp is 20. But so far only who is the latest? Otherwise, who is the youngest reader? 10. Who is the youngest writer? 15. That means no. They are definitely older than you. So no younger transaction read it, no younger transaction writes it. Then it is so far correct order. If you perform your operation, then still you are doing in correct order. That's why definitely you will be allowed, you see. So execute write A and set write timestamp to timestamp of t. So what does it mean? We will see. First of all, the write operation will be done. We are happy. Now once it is done, you see what is your number now? 20. Whenever this condition is false, so definitely this read timestamp and write timestamp both are smaller than your number, correct? That means they are older transaction numbers. Now you are the new writer, right? Then you have to get updated in the write timestamp. That's why we update write timestamp, because you are the new person who wrote it, but your number is definitely greater than those people, correct? Then only we control comes here. That's why directly I go to write timestamp and I say, hello, now I am the new person and my timestamp is greater than existing timestamps. I am the youngest, correct? If he is not youngest, then condition will not be true. Now we'll come to this one. So read of A by T. What if a transaction want to issue read operation? How we handle? We will see. Now if write timestamp of A greater than timestamp of T, this will be checked. Before that we will see our intuitive idea. So what is the meaning of reading? So whenever I do reading, so other transactions can read in out of order also, I don't bother. But really to follow the timestamp ordering, what is the conflict operation? Write operation. That's why I focus on writers. The other writers who are younger, that means younger writers should not write. If younger writers write before I read, then definitely I am not reading correct thing, correct? First of all, I should read according to timestamp ordering. So older transaction has to read, then younger transaction has to update. That is the order. But what can happen sometimes? Younger transaction might write it first, then you may be reading it. How to avoid it? Directly consult. That's why write timestamp. So whenever you are doing read operation, that transaction, first it should consult write timestamp. That's why we are doing. If that write timestamp is greater than your timestamp, example your timestamp is 20, write timestamp is 30, 30 greater than 20. That means what? Already some younger transaction wrote it, but actually what you wanted to have old value, correct? Then only it is timestamp ordering. So younger transaction unnecessarily modified it, but I want to see the old value. It is possible? No, not possible. That's why. So this algorithm says that, so this kind of thing is just now happening. So far it did not happen. So I cancel such transaction who is having this condition. So this timestamp transaction will be cancelled. See, abort and roll back, and I mean whatever the actions performed by your transaction T will be rolled back, cancelled. Now else, when else will happen? See this one, this condition should be false. Write timestamp of A, let's say 20, and your timestamp of T also 20 or 25. 20 greater than 25, condition is false, correct? So now whenever this condition is false, what does it mean? What? So here only older writers wrote it so far. That means you want to read it, but so far only older people wrote it. That means younger people, the people who created after you did not write it. That's why condition is false, right? Then happily we execute read of A. We are in right order. So immediately now maybe this 25 will be the youngest number who read the database item A. Who knows, correct? There are two cases now. Already your read, because we don't know what is read timestamp, correct? So that read timestamp of your A may be 30. If it is 30 means what? You don't need to update your value here, because are you youngest? No. But what if your read timestamp of the database variable is after all just 15? Then we have to make it 25. Finally what I want to say is directly update read timestamp of A to maximum of the current one and your timestamp. So it will get the recent, otherwise youngest thing, correct? So this is the story about basic timestamp algorithm. So finally the idea about basic timestamp algorithm is to allow the transactions in timestamp ordering, correct? So any conflict operation occurs, then that conflicting operation should be done in only timestamp based order. That's it. We'll see one more example and we try to execute this under basic timestamp algorithm. So we know that first of all DBMS executes first operation read of A. So your DBMS maintains read timestamp and write timestamp. So because we are taking only one variable, then only for one variable these two things will be maintained, right? So read timestamp of A initially 0, write timestamp of A 0. Now let's begin. My assumption is timestamp of T4 is 4, timestamp of T3 is 3, in that way. It is 2, it is 1. It is oldest, it is youngest. Now let's begin. So whenever you do this one read of A, what happens? Read operation. For read operation, we only check what? Whenever you are the reader, so conflict occurs only with write, right? That's why the youngest writer will be checked. Who is the youngest writer? No one is there. So when no one is there, then you are in the right order. So far, the system is seeing like T4 is the right thing, correct? That means read of A is the right thing. So it will be performed. So immediately, so since, so one more thing. So I'm just going with my intuitive idea. So if you have any doubt, I mean still you don't understand, directly go to that algorithm and execute it. You can understand. So now read of A will be performed, and since you are the new reader, this will be made 4, correct? After that, this read of A. Again, whenever you have read operation, then we compare with write timestamp. What is write timestamp? Again 0. 0 greater than 3, correct? False. Whenever this condition is false, then operation will be performed. If this value write timestamp is 5 or something, example, that means some younger transaction has already updated, but before that you want to read it, but that will not occur, so you will be cancelled. For that, remember, write timestamp of A should be always less than or equal to current timestamp of the transaction. So at this moment it is correct. So condition is now false. Whenever condition is false, then we perform this operation. Now again go to the read timestamp and update it. What is the maximum value? 4 or current you are 3? 4 only. That's why don't update. Now come here again, read operation. We compare with write timestamp. So what is write timestamp? 0. 0 greater than 2, false. Then we perform the operation and apply set read timestamp to, because you are now new reader, but already youngest reader is 4, so this will not be updated. Then we'll come to here, write of A. So whenever we perform write of A, then we compare against read timestamp and write timestamp, because write read is a conflict and write write is a conflict. So let's do that. First of all, we'll check the readers. Who is the youngest reader? 4. Who is the youngest writer? 0. Correct? So now you want to write it. But so far, only younger people. That means, sorry. So you are the older transaction 2. Correct? But some younger transaction already read it. But what should be the correct order? You should update the value, then others, younger people should read. But younger people already read. That means this transaction will be cancelled, entire thing. Understand? After that, this operation will come. Here again same thing. So current, what is your timestamp? 3. Since you are going to perform write operation, it will be checked against this one, read timestamp and write timestamp. What is read timestamp? 4. That means before your write, some younger transaction already read it, but he has to read from you. Correct? Then only it is correct ordering. That's why again this will be cancelled. Now then, so this which one? Let's assume that this is the next operation. Let's write like this. So write of A, T4. Now whenever you have again write operation, check youngest reader and youngest writer. Who is youngest reader? 4. Correct? What is your timestamp? 4. So the question is, so 4, is this 4 greater than or equal to, is this 4? So now write operation by T4. So if you see here, timestamp is 4, then read timestamp of A. That means who is the youngest reader? 4. So no problem, because 4 and 4 equal, then condition will become false. But younger transaction should not read, correct, before you write. That's a problem. That's the only problem. So it's not a problem. Now here write timestamp. See, what is the timestamp? 0. That means this 0 means T0. That means there is no such transaction. That means so far no one writes it, correct? That means you are the first person, definitely you will be allowed, correct? So that's why finally this time T4 will satisfy the condition. So far T2 and T3 got cancelled. Now we'll see read of A. So if you see this read of A, so what is the timestamp of this T1? 1, correct? Whenever we do read, the conflict operation is write, that's why we'll go for writers. So far, who is the youngest writer? And one more thing, since when this was successful, we have to update here, correct? So this timestamp of A is now 4. Now, when you are reading here in T1, who is the youngest writer? 4. But what is your number? 1. First you should read, then he should write. Now you are going to read wrong data. That's why simply this T1 will be cancelled and it will be restarted. So what I want to say is finally only T4 got perfectly executed. Other transactions are going to be restarted and they will be later executed. That's the idea. Understand? And one more thing. Whenever you restart, so I'm telling that I'm going to restart the transactions, right? Whenever I restart the transaction, example, let's say T1. This T1 when you cancel and restart, then are you going to give same timestamp or different timestamp? If it is different, then what number you give? I will tell you. If this timestamp of transaction is again T1, what's the problem? I will tell you. So already why he got cancelled? Because some younger writer wrote it, correct? That means some younger operations, younger transaction perform some operations. Now if you cancel this transaction and again if you restart with same number, what can happen? I will tell you. Then again if this transaction performs read operation, then we are going to compare with write timestamp. So that again will satisfy the condition, because younger transaction is now again 4. Maybe after some time what can happen, this write timestamp's value might increase to 8 or 9, who knows. Then whenever T1 comes back and again it performs read operation, then again this condition will be same, so that whatever happened to T1, same thing will happen. That means T1 will be cancelled again. Again T2, if it is restarted, T2 will be cancelled again, because conditions are same. That's why what we have to do is, from now onwards, remember, whenever in this algorithm, when transaction is restarted, that will be restarted with, bigger number. That means we finally somehow we say that T1 is now youngest transaction. That means, example, when T1 is created, you are giving number 1, then number 2, number 3, number 4. Suddenly if you cancel T1, but first we cancel T3, right? When we cancel T3, when you restart it, we give number 5, so that we are making it youngest. Then number 6, number 7. In that way, we give bigger numbers, so that this time there will not be any problem for them. Understand? So remember in one line. That means in basic timestamp algorithm, when a transaction is cancelled, then we give a new timestamp. Especially that new timestamp is nothing but so it's such a way that it is the youngest number. That means it's the largest number, I can say. Now we'll see this example. In this example, what is happening is T1 is reading first, after that T2 is writing, then again T1 is writing, then T3 is writing, correct? According to basic timestamp, if you see, definitely it will be rejected. The reason I will tell you. First of all, this is not a problem because it's a first read operation. Then T2, it's a timestamp order, not a problem. Then here, it is not a timestamp order, because so here T1 is writing. Before that, no younger person should read, no younger person should write, but some younger person T2 already wrote it. That's why automatically T1 will be cancelled. But I will ask you one question. This is called actually blind write, correct? Simply focus on the schedule. This is blind write, no reading before writing. So that is called blind write. So when there is a blind write, then what I want to say is, why are you cancelling T1? What's the problem? Because you are thinking that it is out of order, correct? So I will illustrate this problem with one example. So example, you have a variable a value, something initially 0. Now you are reading it, okay, and you are updating it. That means you are making a equal to a plus 10. Then this fellow is blindly making it 20, let's say. Then really, if you follow timestamp ordering, first of all you have to read the data, then after that we have to modify it. That means you have to make it 10. After that he has to make it 20, correct? That means if you see only up to this point, in this one, why this is out of order, I will tell you. The correct order is T1 has to make it 10 and T2 has to make it 20, and since T2 should be last, then the permanent data should be 20. But what's happening here? You are reading, T1 is reading, then after that T2 is making it 20, then later T1 is making 10. According to basic timestamp algorithm, it is wrong, because you are getting different answer than timestamp ordering execution. That's why T1 will be rejected, correct? So what is my suggestion is, however, this is a blind write. Whenever you write, example, let's say you are allowed first. Really, this is the way your transactions has been executed. T1 followed by T2 followed by T3. That means timestamp based ordering. Then what will be the result? Only focus up to T1 to T2. If you do T1 entire thing first, then you will be making it 10, correct? I show here again. So a value 10, initially 0. If T1 is entirely done, it will be 10. Then if T2 is entirely done, it will be 20, correct? But what is happening now? It is now becoming 10. So what is my suggestion is, when you perform up to this point, it was correct, you see. Initially you read 0, then he made it 20. Now don't worry, because if you update it, it is wrong, correct? So however, if you perform your write operation first, then later he executes his write of A, then his data will be permanent, right? His data is going to be permanent if really it is timestamp ordering. But now what I want to say is, if you can somehow skip this operation rather than cancelling T1, now entire thing is correct, you see. Just let me skip this one. If I skip this one, what will be the output? First you read 0, it's correct, then he will make it 20, correct? But if you write it, then you are going to do wrong, but don't update. That means cancel this operation rather than cancelling the transaction. Then still database state is same as if T1 followed by T2 has been done, correct? So that is why what we do is, from now onwards, so there is a variation called Thomas Wright rule. In Thomas Wright rule, what we do is, while writing, we have an exception. So only we see the readers. That means, whenever we update the data, at that time only we check the readers. If there is any younger writer who writes it, we don't care, because if younger transaction writes, however, he has to write it and he is going to modify our data, correct? Then why to bother about it? So when that kind of thing, that means this younger transaction has to write it, but after me, right, after T1, but he did early, right? So why, since he become early bird, what we do is we skip our operation. So that is what we are going to do in, this Thomas Wright rule. Okay. Now we'll see Thomas Wright rule. So in Thomas Wright rule, we know that read is same. That means read condition is same as basic timestamp. But whenever write condition is there, that means any transaction want to do write, then we have to check these conditions. Case number 1. If read timestamp of a greater than timestamp of t, consider this case. You have, let's say, transaction 1 something like t20. That means its timestamp is 20. So it wants to perform some write operation on A. Then what we do is we compare read timestamp of A. Then currently, who is the youngest reader? If youngest reader is 30, that means what? So I will tell you. So timestamp of T is, let's say, 20, 30 greater than 20. That means so far actually you have to write the data that should be read by 30, correct? Then only it is timestamp ordering. But what is happening here? Reverse happened. So already the younger person read it. Now you are updating it. So now we can't rectify it, correct? We can't ask him to again come and read, correct? Example, so come to our real world analogy. Example, let's say you want to read a newspaper. You are reading a newspaper, but the order is, so today date, let's say something 15. Tomorrow will be 16, in that way. You want to read in this order. 15th paper, then 16th paper, 17th paper. Then what happened? Already you read 16th paper. Now you want to, but always you want to read in 15, 16, 17 order. But you read 16th order. What can we do now? So again you have to read 15, then 16, 17. But of course I can do it. But whatever I read 16, can I forget? No, I can't. That means now no one can change the order. Correct? So same thing now happening here. Whenever younger transaction already read, then we can't do anything. Simply we cancel the transaction T. So that is what happening, you see. So about T and roll back. That means whatever the effects this T has been done so far will be reverted. Then it will be restarted later. We know how it will be restarted, correct? With a new timestamp, correct? Which is nothing but largest in the system. Now, if write timestamp of A greater than timestamp of T, if this condition is false, that means what? Then only will come here, remember. So that means so far writers are good. That means let's try to violate this condition. Your timestamp is 20, right? Let's take 15. 15 greater than 20 false. That means so far only we are coming in order. That means all the readers. That means all the readers you see. Highest reader is 15. That means now only readers are in the right order, definitely. Now we will see writers. So if write timestamp of A is again 30 and your timestamp is 20, 30 greater than 20, true. That means what? Actually you have to write, then this younger person has to write, but what happened? Reverse has been happened. Then how to rectify? We can rectify in Thomas Wright rule. That is the difference between basic and Thomas. See, in Thomas Wright rule what we say is, however, if we write it, then later he is going to change it. Now definitely this is blind write. How can we say that? If this is not blind write, he is not a blind writer. We know who is blind writer, correct? Blind writer will have only write without read. How can I say he is blind writer? I will tell you. He is not blind writer, then his write will be preceded by read operation. Then he is also going to do reading. If he reads really the database item, then the youngest reader will be 30. He is not 15. Then if this condition is satisfied by write, then read condition also will be satisfied. Then here itself we will be satisfying the condition and our transaction will be cancelled. Correct? So that's why, so it is not blind write, correct? So if we skip this condition, that means, and if you satisfy this condition means what? This person, transaction 30 person only wrote it but not read it. That means it's a blind write. Whenever there is a blind write, what happens is, so I can imagine that like this. So this is blind writing right up here. But this is like say my transaction T20. T20 has to, he's younger person. I have to write first, then later he has to write. But what happened? Reverse has been happened. But this T30 wrote it first, then T20 you are writing, correct? Then how to rectify it? However, it's a blind write. If you write first also, he is going to replace your data. Then better you pretend like this. So nothing has happened, you pretend like you wrote it, then automatically that is what. So with example easily we can understand your T20 T30. So actually what happened, you should write first, then later he should write, but what happened, mistake has been done, T30 wrote it. Now the data is currently, now if you write it that will be wrong, if you don't write it's perfectly right, correct. So that's why already I explained you clearly that. So whenever this thing happens, then skip the write operation. If you skip your write operation, so exactly we will be following timestamp ordering. So no need of cancelling your transaction and no need of wasting our resources. So if this condition also false, when it will happen? Example, read timestamp is 15, write timestamp is let's say 25, your timestamp is 30. Then in this scenario, 15 greater than 30 false, 25 greater than 30 false. That means, so current transaction 30 is definitely younger than readers, younger than writers. That means only older people read and older people write. It's a right order. Then I have to perform that operation. That's why. So that times, I mean that transaction will be writing it, not a problem. So perform that write operation of the transaction and set write timestamp, because now you are the new writer, right? So successful write always should update write timestamp. So write timestamp will be updated by your timestamp. The reason, at this time whenever you come to this point, these two conditions will be violated. Whenever these two conditions are violated, then read timestamps and write timestamps are smaller than your timestamp, then you will be, your timestamp will be bigger. So we have to update here. Directly we can update without comparing, right? So this is about Thomas Wright rule. So in the exam, if they give a question and they give a schedule, they ask whether it is allowed under Thomas Wright rule or not, then simply apply these conditions. Understand? So now I will give you an example and we'll check whether that is allowed under basic timestamp and that is allowed under Thomas Wright rule or not. Okay. Now we'll take this schedule and execute under Thomas Wright rule and basic timestamp algorithm, and we'll check whether it is allowed or not. So here what you do is you need practice and you should understand the intuition. If you understand the intuition, it is easy. Otherwise, at least to get the intuition, take that algorithms and practice this one. Now since I have a lot of practice, then I got some intuition. That intuition I will tell you. That is, see, our order is timestamp order T1, T2, T3, T4. In that order if you perform, there is no problem. That's why T2 correct order, then T3, T2 to T3, no, okay. So T4 no problem. So far there is no problem, but we have to maintain read timestamp and write timestamp, correct? So read timestamp of A so far is, who is the youngest reader? 3, right? So who is the youngest writer so far? Write timestamp of A, if you see, so far this is correct, right? Only one writer wrote it, that is 4. Now this write operation next. Now according to basic timestamp, when you are writing, reader should be correct order, writer should be correct order. Now your number is 3, but you see this write timestamp says that I am not in correct order. That means 4 says that I am not in the right order. That's why what we do in basic timestamp, simply we cancel T3. Okay, so we cancel T3. I'll mark like this. Then let's perform. That means this operation will not be performed. Now we'll see this one. So again same thing. When we are writing in basic timestamp, we see the writer's order, reader's order. So go to reader's order. Reader's order is wrong, writer's order is wrong, because these people are younger than this one. Then this transaction also will get cancelled. In the exam they can ask this kind of questions. So how many transactions will be cancelled? T1 comma T3. How many operations are violating this basic timestamp rule? This one and this one. In that way we can understand. Now we will see Thomas Wright rule. So to understand Thomas Wright rule, only thing is read is same, but only write condition is different, right? So in write condition, if readers are okay, that means reading is in the right order, but writing is the only different order we will manage. How we will see? So initially, same story, read, okay. So far if it is in right order, there is no problem. Timestamp C, read of A, first operation it will be allowed. Then read timestamp will be updated to 2, correct? Now next this one, T2, T3, timestamp ordering, then it will be allowed. Then reader, new reader will be 3, that means youngest reader. Right timestamp of A is, let's write A, here A. So far no writer, now first writer here. So definitely it will be allowed and condition will be satisfied. this will be 4. Now this operation comes. What is the rule? Whenever you are writing, now I am executing Thomas Wright rule. In Thomas Wright rule, we just check the writers, correct? So first of all, we'll see readers. If readers are good or not. Readers. So 3. Yes. So your number is 3, right? So far only up to 3 people. That means only older people read it. Then no problem. Now we will see write condition. What about writers? There is one, so there is one younger person who writes it. Then what to do? Then read condition is correct, but only write condition is false. We skip this operation, but we don't cancel. That is the specialty of Thomas Wright rule. But in basic timestamp, it got cancelled, right? So now don't cancel T3. Now come to write of A. Same story. First check readers. Readers are in right order? No. Readers are C. So far, maybe 1, 2, 3 among them someone read. Who is the youngest reader who read? 3. Now what is your number? 1. Correct? So this T1 wants to write some database item, but before that some younger people already read it. Now you can't correct it. How can you say to this younger people that, my dear younger person 3, you should not read. Now you have to read. We can't say that because already he read it. We can't cancel it. Correct? That's why in Thomas Wright rule also, whenever you get this kind of situation, what is that? If readers are out of order, see, you are now, when we are checking write condition, if readers are out of order, that means what? Younger people already read, we can't do anything. Simply cancel this one and cancel transaction T1. So finally, this schedule is not allowed under Thomas Wright rule and basic timestamp, but at least it is better, and it is only cancelling T1. And in the absence of this T1, if the problem is whether this schedule is allowed under basic timestamp, no. So we got cancelled some transaction, right? Second, is it allowed under Thomas Wright rule? Absolutely. So far up to this point it was allowed, correct? So in that way you can understand, Thomas Wright rule. Second one, basic timestamp. In the GATE exam, there are very rare questions related to this algorithm. So far from transaction concurrency, most of the time, 90% of the time, they asked questions from, conflict serializability, view serializability, recoverability. Very rarely, in only 10% of the time from transactions, they ask questions from these other things like, 2PL protocols, Thomas Wright rule, basic timestamp, and we are going to see multi-version protocol and multi-granularity protocol and, deadlock prevention algorithms. From all that, very rarely they are asking questions. That's why you just attend my lectures. That's it. You can answer any GATE question if they ask. So here from this Thomas Wright rule, if you know the algorithm, they might ask what is the read timestamp at the last, what is the write timestamp after executing so-called this transaction, otherwise this operation. In that way they ask. They can ask one typical question like this: after executing T3's write of A, what will be the status of read timestamp and write timestamp? If you know the algorithm, you can solve. Not a big deal, correct? So this is about Thomas Wright rule and basic timestamp protocol. These two are timestamp based protocols. Now we will see some of the properties of these protocols. One is, this is deadlock free algorithm. What is that? Timestamp based algorithm, whatever, basic timestamp and Thomas Wright rule, both are deadlock free. Why? We are not keeping locks. When you don't keep locks, and second thing, are you blocking anything? No. In basic 2PL and other 2PL algorithms, you block transactions, then there was a possibility of getting deadlock. But here we are not blocking them. We are simply cancelling the transactions, but no transaction in Thomas Wright rule or basic timestamp was waiting. When there was no waiting, how can you have deadlock? So that is quite obvious question. So finally, timestamp based protocols avoids deadlock. Second thing, so we have to answer these questions. One is, so basic timestamp and basic timestamp and Thomas Wright rule, what is their capacity? That means what they allow. Question number 1, what about conflict serializability and timestamp based protocols? Are they related? Second one, what is the I can say capacity, otherwise what is the expressive power, otherwise what is the acceptance power of these timestamp based algorithms? We will see that. Okay, now we'll see the relationship between various protocols one by one: basic timestamp, Thomas Wright rule, and view serializability, 2PL, and conflict serializability. So first of all, we begin with basic timestamp and Thomas Wright rule. Thomas-Wright rule is a superset of basic timestamp. It's quite easy to understand because Thomas-Wright rule is a lighter version of basic timestamp. So there is a strict condition in basic timestamp, whereas in Thomas-Wright rule we have a little bit, I can say relief, correct? So that's why Thomas-Wright rule is superset of basic timestamp. Now this basic timestamp is covered under conflict serializability. That means if a schedule is allowed under basic timestamp, automatically that is conflict serializable. Why, we will see. The reason is, first of all, please recall basic timestamp idea. Example, you have three transactions T1, T2, T3. Their timestamps are 1, 2, 3, right? So we will be allowing this schedule if and only if the conflict operations called read, write in following order. What is that order? 1 followed by 2 followed by 3. That means, so the timestamp ordering is T1, T2, T3. In that order, only if you have conflict operations in your schedule, we allow it. Example, only one thing you see. Example, T2's write is here and conflict operation is read, right? Otherwise write, doesn't matter. Please recall basic timestamp algorithm. When you have this kind of schedule, what happens? First of all, this is allowed. Then when you see this read, definitely this T1 will be cancelled. That means overall we are not allowing this kind of schedule. We simply say that T1 has to read first, after that T2 has to write. So because of that reason, I can say that whenever you have a schedule where all the conflict operations are in timestamp order, like what is timestamp order here? T1 followed by T2 followed by T3. If your operations are in this order, then only we are allowing. So when you have conflict operations in this order, we can separate that instructions into three parts: all T1 followed by all T2 followed by all T3, because we have some particular order in the in the operations. So you are definitely such schedule, whatever which is allowed under basic timestamp will be ordered like this: T1, then T2, then T3. So automatically that is serializable, correct? That's why it will be conflict serializable, right? We can separate them into some serial schedules. So that is the rough idea. So you just remember that. If you don't understand this idea, no problem. Simply remember that basic timestamp allows conflict serializable schedules. That's it, not more than that. But Thomas-Wright rule allows some extra. That means it can allow more than conflict serializability also. We will see what is the reason for that. Consider the schedule, you will understand completely. Example, you have T1, T2 and read of A and let's say write of A followed by write of A. Actually it is view serializable schedule. Please check it out. So you know view condition, right? So go through view serializability and just execute it. You realize that this is view serializable but not conflict serializable, but it allows under Thomas-Wright rule. The reason, first this operation will be allowed and read timestamp of A will become 1, correct? Because now new reader. Now see write operation. The order you see read and write are in timestamp order. This is timestamp of T1 is 1, timestamp of T2 is 2. Then we are following timestamp order. So this operation will be allowed, write operation. Because of that, write timestamp of your because of write of A, write timestamp of that variable A will become 2, correct? Now later you will see write of A. So what we do, we just first of all will see read operation, right? So read timestamp 1, that means only so far older transactions read, then condition is satisfied, and we'll compare write timestamp. Since write timestamp is bigger, at that time if you see Thomas-Wright rule, simply we cancel this operation but we don't cancel T1 or T2. So we are finally allowing the schedule, correct? So by skipping this operation, we simply skip this operation, correct? So in that way, by skipping this operation, we allow this schedule. That's why finally you allowed this kind of schedule, correct? That's why your schedule is view serializable. That means Thomas-Wright rule is allowing this schedule which is not conflict but view. That's why I put this area. So finally if you see, this Thomas-Wright rule is having some extra area, this one. This is definitely outside conflict serializability, and especially that is view serializable schedules, right? So finally, if someone asks, every schedule which is allowed under Thomas-Wright rule, is it conflict serializable? Need not be, because there are some points which are outside conflict serializable. Now we'll see the relation between basic timestamp and 2PL. Just remember it. So 2PL and basic timestamp, they are quite different, independent. So there are some schedule which are, see this one, there are some schedules which are allowed under basic timestamp, but they are not allowed under 2PL. See the circle of 2PL only up to this point. That means there is a point which is in basic timestamp but not in 2PL. Similarly, there is a point which is in Thomas Wright rule. That means, of course, obviously this point is pretty clear. You see, 2PL only allows conflict serializable schedules, but your Thomas Wright rule is allowing beyond that. Then definitely this kind of points are allowed under Thomas Wright rule, but they definitely are not allowed under 2PL. Similarly, there are some points which are not allowed under Thomas Wright rule but allowed under 2PL. There are some 2PL protocols, otherwise there are some schedules which are allowed under 2PL cannot be allowed under basic 2PL. Similarly, basic timestamp. Similarly, there are some points which are in basic timestamp but not in 2PL. That means there are also some basic schedules which are allowed under basic timestamp but not in 2PL. Similarly, there are some points just now we covered which are in Thomas Wright rule. That means which can be accepted by Thomas Wright rule, but they might not be accepted by 2PL. Here 2PL means every 2PL. That means you can treat it as basic. That's why I wrote 2PL. In the place of 2PL, you can assume basic 2PL, you can assume conservative 2PL, or strict 2PL, or rigorous. So for everything I can say same thing. That means, example, you want to talk about rigorous 2PL. There is a schedule which is allowed under basic timestamp but not allowed under rigorous 2PL. There are some schedules which are allowed under rigorous 2PL but not allowed under basic timestamp. In that way, timestamp algorithms, these two are I can say that there is a intersection, right? That means there are some schedules which are allowed under both timestamp and 2PL, but there are some schedules which are only allowed under basic timestamp, only allowed under 2PL. Similarly, there are some schedules which are allowed under only Thomas Wright rule but not 2PL. In that way, 2PL and timestamp, these two are, I can say, the relation between them can be seen like this. Okay, so let me focus on this 2PL and timestamp. Let's say this is timestamp, this is your 2PL. So there is an intersection. Now this timestamp, you can take anything. So this rule works for everything. You can use Thomas Wright rule also. That means if you treat this as Thomas Wright rule, if you treat this as whatever the 2PL you want, let's say rigorous 2PL, then I can say like this. So this schedule which is allowed under Thomas Wright may not be allowed under rigorous. There is a schedule which is allowed under Thomas Wright rule and rigorous 2PL. There is a schedule which is allowed under rigorous 2PL but not allowed under Thomas Wright rule. Now you can remove this rigorous and you can substitute basic also. Same thing. There is a schedule which is allowed under basic 2PL but not allowed under Thomas Wright. There is a schedule which is allowed under Thomas Wright but not under basic 2PL. There are some schedules which are allowed under both basic 2PL and Thomas Wright. In that way, in the place of this TS, timestamp based protocol, you can use Thomas Wright, otherwise basic. Still this relation holds good. That is what I want to say. Let's finally finish it up with a random example. Let me, from timestamp I take basic. From this I take conservative. What is the relationship if someone asks? Same thing holds good. That means there are some schedules which are allowed under basic but not allowed under conservative. There are some schedules which are allowed under conservative but not allowed under basic. There are some schedules which are both basic and conservative. In that way you can understand. That's why you remember simple this picture. Understand? So this is a story about various protocols and serializability. Okay, just remember this diagram so that you can answer lot of questions, but very rarely they ask this kind of questions. These are all memory based questions, right? So very less reasoning is there. That's why most of the time they don't ask questions from this area, but just if you attend my lecture and whatever I cover, that's more than sufficient to crack, otherwise answer any gate question for sure. Okay.